Hi everyone, it's Mr. Canfield. Today we're going to look at the area between curves, also known as the ABCs. Dumb. All right. So, our warm-up says, find the area of the shaded region if the curves are y equals negative x squared plus 9 and y equals negative x squared plus 4. And so I've already drawn the parabolas and colored it in. And so if we're trying to find this region, we could... Let's see. Well, we're going to wind up needing the area underneath the big one, so we could always find the area underneath y equals negative x squared plus 9 by taking the integral. What would our bounds be? Let's see. It looks like it intersects the x-axis at 3, or negative 3 and 3, which match with the function. So if we took the integral from negative 3 to 3 of negative x squared plus 9 dx, that would give us this kind of bigger region, and then it looks like the area underneath the other one is removed. So what if we took from negative 2 to 2 negative x squared plus 4 dx, and what if we just took this one and we subtracted that one? Would that make sense? Then that would be, yeah, because it would take away this little mini area of the big area and it would just leave this outside portion. And that's all we would need to do. So let's go ahead and do that. So then we would get negative x cubed over 3 plus 9x evaluated from negative 3 to 3. And then we're going to subtract negative x cubed over 3 plus 4x evaluated from negative 2 to 2. And that's literally all we would need to do here. So I'm going to go to my calculator and just kind of shortcut this a little bit. So let's see, we've got a negative 27 over 3 plus 27 minus negative 3 cubed is negative 27 still, so it's going to be positive 27. 27 over 3 minus 27. Okay, that's our first integral, and our second integral is going to be, let's see, negative 8 over 3 plus 8 minus positive 8 over 3 minus 8. All right. Now, you need to be careful with, there's a lot of pluses and minuses going on here. Let's see. So, first of all, I see the negative 27 thirds and the negative 20, it's negative 54 thirds. Well, hold on, 27 thirds is 9. So it's negative 9 and negative 9, that's negative 18. Then plus 27 minus 27, that's plus 54. So negative 18 plus 54, let's see. That's 44 minus 8 more is 36. And then we're going to be subtracting whatever we get in this one. So we're doing negative 8 thirds twice, that's negative 16 thirds. Plus 8 plus another 8 is plus 16. That's 48 thirds minus 16, 32 thirds. So I got 36 minus 32 thirds. So if I multiply this by 3 over 3 to get the same denominator, it's 108. So 108 minus 32, 76 thirds. I'm going to do a divide by 3 check, so 76 thirds. 7 plus 6 is 13, so it doesn't divide by 3. So I got that for my answer when I did it by hand. Let me just go and double check in the calculator. Okay, got the same answer for that one. It's not going to be any faster to do this, like repeating it. Let's see, negative x squared plus 4 dx. Whoops, nope, dx. That was, all right. So, cool, got the same answer. Good to know. All right, I did arithmetic correctly for once. We are not normally going to be doing these out by hand. Normally what we're going to be doing is we're going to be setting up whatever integrals we're doing, and then we're going to be using the calculator. So before we do that, this is a pretty straightforward example. I want to generalize this. And this example actually doesn't fit into the general area between curves that we're looking at. Normally what we do is we find the area between two curves at their intersection points. So normally what we're going to wind up doing is we're going to find out where these two curves intersect. You know, somewhere down here. I don't know exactly where they're going to intersect. I could cheat. And see that they intersect off my screen somewhere. So they're going to be intersecting somewhere down here and down here. And we normally are going to find that whole region with squiggly legs and all. All right, so let's talk about it in general, and then we'll do some examples. All right, so how does location affect area? So, well, you're going to focus? All right, so let's say both curves are positive. So if we're looking at this, if we're trying to find the area between these two curves, that's this shaded region right here. Well, let's think about this. We have from A to B, and we have our top curve looks like this. That means the area of our top curve between that and the x-axis is going to look like this. And then we're going to have to take out this other area, this area that looks like this. If we were to take this and remove that, we'd be left with that. And so this is actually going to be the integral from A to B of, let's see, which one's on top here? Looks like f of x, okay. F of x minus g of x dx. We could do that with a single integral there. Say this area minus this area. Let's move on to the next one. So in this one, if I want to find this area, it's the same area. I copy pasted the picture, but I moved the picture up and down so we can understand. So in this one, so in this one, it looks like we're going to be taking this unintentional happy face. We're going to be taking this area, and then we're going to be subtracting away the other area. Because remember, the area is always between the function and the axis. So it looks like this time we're going to be taking the g of x area, and we're going to be taking away the f of x area. But let's think about this for a minute. What kind of number do we get for the g of x area? We get a negative area. So we're getting some negative number, and we're going to be subtracting out another negative number. Because we want to find out, this is a positive area that we have in here. Turns out, the way that the negatives work here, we have a negative number for the g of x, we have a positive number for the f of x. All you have to do is take the area from A to B of f of x minus g of x dx. Because the way that the negatives work, we need to find the positive area between these two. If we were to do g minus f, we would get a negative result. And so the way that we actually find this is using just the normal. And so you might be able to guess the punchline is it doesn't matter how much is above or below. We only ever have to do the area from A to B of f of x minus g of x dx. It is always the integral from intersect to intersect of top function minus bottom function dx. This will always work. Intentional happy face. All right, let's keep going. So now that we've talked about the concept, let's do some application and learn how to turn pages. Okay, so, you know what, do I have my bigger copy of the notes? These aren't super readable like this. A good teacher plans ahead. I don't. All right, here we go. So it says, example, find the area. Oh, hold on one second. My wife just texted me.